Hello everyone, I'm Adisa and today I will explain a little bit about ion fertilization experiment. First of all, let me explain briefly about what is ion fertilization. Ion fertilization is an innovative method to reduce the atmospheric carbon dioxide by adding the ion at the water surface in order to enhance the phytoplankton growth. This is because iron is known as an essential micronutrient for phytoplankton to utilize macronutrients such as nitrate and phosphate. Martin hypothesis has suggested the effectiveness of biological pump together with the ion enrichment in order to encourage the phytoplankton response. For the past 25 years ago, there were several experiments that have been conducted in several oceans in order to test the hypothesis. The aim for all the experiments, of course, to reduce the atmospheric carbon dioxide. Scientists managed to trace the atmospheric carbon dioxide level during the last glacier maximus, which is about 20,000 years ago, by analyzing the trapped air bubble in Arctic and Antarctic ice core. This discovery has shown how the natural dust during that time have been the ion source for the ion fertilization and biological pump. As the result, the carbon dioxide level during that time, which is the last glacier maximus, is lower than during the pre-industrial time. For the past 25 years ago, from 1992 to 2011, there were about 13 artificial ocean ion fertilization and 6 natural ion fertilization have been conducted at the several oceans. The experimental area for the experiment were including the high nutrient low chlorophyll region, which is the Southern Ocean. Right? The experimental area for this experiment were including the high nutrient low chlorophyll region, which is Southern Ocean, North Pacific, and the Equatorial Pacific. While for the low nutrient and low chlorophyll region, which is the subtropical North Atlantic. The region have been chosen because of the high level of macronutrient, but the low chlorophyll abundant because of the low iron present for the phytoplankton growth. This brings the scientists in geoengineering interest to enhance the biological pump and ion fertilization in order to reduce the impact from the increasing of the carbon dioxide level in our atmosphere. As the result from all the experiments, only SOFT-XN and IFEX experiment at the Southern Ocean has shown the significant export flux event and the carbon export in deeper layer. The failure has been influenced by several limitations. The limitation including the fertilization subduction because of the only one ion injection, which create the small patches. Next was the insufficient experimental duration, which is not more than 40 days like the Iron X1, which only conducted for 10 days. They could not observe the fully response from the phytoplankton. The micro and macronutrient limitation already reduced the phytoplankton development. The other mistake they made was there is no comparison between one and another experiment to find the differences between each other, and there are no measurement for the deep sea export flux. During the ICE experiment at the Southern Ocean, there was a storm which led to the light limitation. Lastly, due to the small injection of the iron, the fertilized water faced the lateral dilution with the unfertilized water and the dissolved silicate, which brings to the iron limitation. So, how we can relate the iron with the climate change? Answer is because due to the increasing of carbon dioxide at atmosphere because of the human activities, of course you want to find a solution how to reduce the impact from it. So, scientists try to find a solution by generating the phytoplankton growth by fertilizing the iron for them. If we over-adding the iron at the water surface, it might lead to the diatom bloom that can harm the environment. It is also possible to encourage the related climate gases such as methane and bring to oxygen dissipated underwater. From the previous 25 years ago experiment, we want to continue this study in order to reduce the impact of the carbon dioxide level increasing at the atmosphere, but with some more improvement. Basic step for the future OIF can be conducted efficiently. Firstly, future OIF can be conducted at the region with high concentration of silicate and low grazing pressure. Ocean ATs are also the excellent area to be chosen as they are naturally isolate the interior water from the surrounding water and can easily detected by the satellite. This is important as you want to control the diatom bloom and observe the ion induced. Secondly, from the previous study, It is recommended for the future OIF to be conducted during the early summertime, which is in the late December until the early January, to ensure the limitation of macro and micronutrient is controlled and the light is available for the phytoplankton groups. So for the future OIF, we need to make sure the experiment should be extended a minimum 40 days to ensure the iron fertilization effectiveness on the iron-induced bloom. Next, the future OIF needs strategy to maintain the iron dissolve. It is suggested to use the acidified iron sulfate as it is more bioavailable and more affordable. Study, the fertilized patches need to be in the light scale in order to reduce the effect from the dilution with the unfertilized area. And the process for the iron fertilization also need to be done within the 24 hours because of the time dependent for phytoplankton to respond. The autonomous observation platform also needed as we want to use to observe the risk of the OIF after the experiment termination, and multiple iron infusion is needed to reduce the iron limitation. For the tracing method, the future OIF need the carbon sequestration and patches detection for a successful experiment. The application of physical and chemical tracing are efficient for the tracing of the patches and the carbon sequestration. Lastly is the side effect. After the LPLC adopted the assessment framework for the scientific research involving the ozone fertilization, it is important for the future OIF to monitor the side effect from the OIF experiment, the production of the climate-related gases, and the negative ecosystem changes should be monitored in order to evaluate the effectiveness of OIF experiment. The possible effect can be observed from the optical sensor equipped autonomous mode profilers and the autonomous benthic vehicle to measure the benthic oxygen for the long term. That's all for me for the iron fertilization. Thank you for listening, and I hope everyone is understand with my explanation.